let's discuss how to work with arrays when using Redux. We will do this with the help of an example. So this is the UI wireframe of the example that we are going to implement. In this example, we are going to allow the user to manage a list of Tom Sawyer's friends. So the user can add the name of a friend using this input text box over here, and then by clicking on this add button over here. And once a name is added like that, that name should be displayed over here in the list of Tom Sawyer's friends. And we also want to give the user the ability to remove a friend. So we have to do three things. We have to show the existing list of Tom Sawyer's friends over here. And we also need to allow the user to add to that list. That means add a friend to that list. And we also need to allow the user to remove an existing friend from the list. So for this example, we will maintain this list of friends in an array that will be managed by a reducer. And in that reducer, we will have two operations. One operation to add a friend to the array and an operation to remove a friend from the array. Let's discuss three common ways to add an element to an array and remove an element from an array. First, let us discuss how to add elements to an array. So three common functions that help us to add an element to an array are push, concat, and we can also use the spread operator. And three functions that help us to remove an element from the array are splice, slice, and filter. As you can see here, I have put these methods under the headings mutating and non-mutating. I have put the push method under the mutating heading, and I have put the concat and the spread operator under the non-mutating heading. We'll discuss what that means in a moment. Similarly, I have put the splice method under the mutating heading and the slice and filter methods under the non-mutating headings. Before we start implementing the example that I showed you in the UI wireframe, let us quickly discuss these methods using the browser console. We will be discussing these methods and how they work, and we also want to understand what the terms mutating and non-mutating mean in this context. So let's go to our browser console and open up the developer tools and try out these methods. So I'm going to open my browser developer tools by right clicking and clicking on inspect, and then I'll go to console. Let me zoom in just a little bit so that you can see this more clearly. And now let us do a few examples using these methods over here. Let us start with the push method. So I'm going to define an array over here called ARR, and I'm going to assign 100, 200, 300 as the elements of the array. And I'm going to press Shift Enter so that I can write more lines of code before executing the code. And in the second line, I'm going to type arr.push, and I'm going to pass 400 as the argument to the push method. And on the third line, I'm going to write console.log, and I'll pass arr as the argument to it. So I'm going to click enter now, and as you can see, arr now has 4 elements. 400 got added to the array as the last element, as you can see over here. Now let us try the concat function. I'm going to click the up arrow to get back the previous code, and in the second line of code, I'm going to modify the push to concat. As you can see here, I have replaced the push function with the concat function. I'm passing in 400 just like in the previous example. Let me press enter and let's see what the output will be. As you can see here, when we logged ARR to the console, we got back the original 3 elements of the array. This number 400 was not added to the array because you can see in the output over here that 400 is not there. So then the question is, what did this statement do? And to answer that question, let's modify the second line of code slightly. I'm going to press the up arrow once again to get back the previous code, and I'm going to modify the second line of code like this. I'm going to type arr2 equals arr.concat of 400. So what I have done is I have placed arr2 equals to the left hand side of this expression arr.concat of 400 so that it becomes an assignment statement. And now let us log arr2 also to the console. I'm going to press enter and let's look at the output. As you can see here, ARR is 100, 200 and 300. It's unchanged, while ARR2 is 100, 200, 300 and 400. So ARR2 has the elements of ARR as well as 400. And the important point to note is that when we call the concat function on ARR, it did not modify ARR. the concat function returned a new array which got assigned to the variable arr2. This is unlike the push function, which when called on arr, it ended up modifying the array with which it was called. As you can see here, when we called arr.push and we passed 400 as the argument, arr itself got modified, because when we logged arr to the console, we can see that 400 got appended to the array arr. Since the array on which the push function was called got modified, we classify the push function as a mutating function. The word mutate means change. So what we mean here is that the push function changes the array on which it is called. Since it changes the array on which it is called, we say that the push function mutates the array on which it is called. So we can say that it is a mutating function. And in contrast, the concat function does not modify the array on which it is called. Since it does not change the array on which it is called, we classify that as a non-mutating function. However, what it does is it returns the new array as its return value. As we can see here, arr2 has the elements of both arr as well as the element 400, which was passed to the concat function. So it is important to remember that some functions in JavaScript are mutating functions and some of them are non-mutating functions, and we have to use the correct one according to our needs. Let's do the same example using the spread operator also. The spread operator is also non-mutating. Let's look at how it works. I'm going to press the up arrow to get back the old code from the previous example, and I'm going to modify the second line of code. On the right hand side, instead of using the concat function, I'm going to use the spread operator. I'm going to open the square brackets and I'm going to use the spread operator over here, and I'm going to spread the array arr so that the elements of arr come into this new array over here, and I'm going to append 400 as the last element of this new array, and I'm going to close the square brackets. Let me press enter and let's look at what the result is. As you can see here, arr is unchanged and arr2 has the elements of arr as well as the new element 400. So this output is the same as this output out here. So when we want to add an element to an array in a non-mutating way, we can use either the concat function or we can use the spread operator. And if we want to add an element to an array in a mutating fashion, we can use the push method. Let us next discuss how to remove an element from an array. Let's start with the splice method. Let's say we have an array arr which has 5 elements: 100, 200, 300, 400 and 500. And let's say we want to create a new array which does not have this element 300 in it. So we can write arr.splice, and the first parameter, as you can see here, is start, and the second parameter is the delete count. Please ignore the third parameter for now. This third parameter will allow us to add items as well, so let's ignore that for now. So if we take a look at the first two parameters, the first parameter is start, and that means the start index. So if we count the index over here, 300 has the index 2 because 100 has the index 0, 200 has the index 1, and 300 will have the index 2. So I'm going to type 2 as the start argument, and I'm going to type 1 for the delete count. That means the number of items that we want to delete. We just want to remove the element 300, so that is just one item. So let's pass in 1 as the second argument. And then as the third line of code, let us log arr to the console. I'm going to press enter and let's look at the output. As you can see over here, arr has only 4 elements now, and you can see that 300 is no longer a part of arr. So we have successfully removed 300 from the array arr. And since splice is modifying the array on which it is called, it is a mutating function, and that's why I have listed splice under the mutating heading over here. Now let us take a look at a couple of non-mutating functions. Let us start with filter. Again, let us have an array with 5 elements over here: 100, 200, 300, 400 and 500. And as I mentioned here, filter is a non-mutating function, so it will not modify the array on which it is called. It will return a new array with the filtered elements. So I'm going to say ARR2 equals ARR dot filter, and now we have to pass in a predicate function to filter the elements of the array. Let's say we want to get rid of the element 300. Then we can write this in a couple of ways using the filter function. We can write a predicate function to directly compare with 300. Let's write an arrow function for this. X is the parameter, and the body of the function should be a condition. So we have to write x not equals to 300 like this. What this will do is each element of this array ARR will be compared with 300, and those elements that are not 300 will be returned in the form of a new array, which will then get assigned to ARR2. And as the third line of code, let us write a console.log statement, console.log, and let's log ARR as well as ARR2 to the console. I'm going to press enter, and let's look at the output. As you can see here, ARR is unmodified, which is to be expected because we discussed that filter is a non-mutating function, so it will not change the array on which it is called. And ARR2 is the new array that has been created by the filter function, because the filter function returned a new array and that got assigned to the variable ARR2. And you can see that 300 is not a part of this new array over here. If we wanted to filter out this element 300 using its index rather than its value, then we could have written the second line of code like this: ARR3 equals ARR.filter, and filter actually takes in two arguments. So we can write x comma index, and then in the function body we can write index not equals to 2, because we want to filter out the element with index 2. And if we log ARR3 to the console, we can see that we get the same output as before. The new array does not have the element 300. So we can use the filter method in a couple of ways. We can either compare with the value directly, or we can use the index also. And finally, let's discuss the slice function. That is also a non-mutating function. So let's take a look at that. Again, I'm going to start with an array ARR equals 100, 200, 300, 400, and 500. And let's say we want to remove this element 300 over here, and we want to get a new array which does not have this element 300. In order to use the slice function for this, what we'll have to do is we'll have to use a slice function to get a hold of these two elements over here and then concatenate that with these two elements over here. That means to get rid of this element 300, what we'll end up doing is we'll have to use a slice function to get this array over here with the elements 100 and 200, and this array over here with the elements 400 and 500, and then we'll have to concatenate them both. So let's do that. So I'm going to type ARR2 equals ARR.slice, and slice expects at least one argument, but in our case we need to pass in two arguments. We want to pass in the start, which is going to be 0 because we want to start from the 0th index. And the second argument, as you can see here, is end. That means we have to pass in the index of the ending element. But the confusing point to remember about slice is that whatever is passed in as the ending index does not get included as part of the resulting array. So in order to get 100 and 200, we'll have to pass in the index of 300 as the value for this second argument over here for end. So let's pass in the index of 300 as the second argument, and the index of 300 is 2. And once we do that, we will get 100 and 200. Now let us try to get hold of 400 and 500. So let's use another variable for that. Let's say ARR3 equals ARR.slice, and similarly our start has to be the index of 400, which is 0, 1, 2, 3. So just 3. And when we want the rest of the array from the start, we can omit the second argument. So we can just pass 3 and close the brackets like this. And so we have our two arrays now ready, and now we need to combine them both. Let's use another variable called result, and let us use the spread operator to spread the contents of both ARR2 and ARR3 so that both those arrays are combined and the resulting array is returned as a new array into the result variable. And I'm going to write console.log and I'm going to log result to the console. So let me press enter now and let's look at the result. As you can see here, the output is 100, 200 and then 400 and 500, which is exactly what we wanted. We wanted to remove 300 and get a new array, and that's what we got over here. And if you look at ARR, it is unchanged because slice is a non-mutating method. Instead of using 3 lines of code for achieving this, we can achieve that in a single line of code as well. We could have written result equals, we could have opened our square brackets over here to indicate a new array, and we could have used the spread operator over here, and we could have written arr.slice of 0, 2, and then we could have specified the spread operator again, and we could have written arr.slice of 3, and we could have closed the square brackets over here. And if we log result to the console, we'll get the same output. So we have discussed all of the methods that are listed on this slide. So the question now is, which of these methods to use when we use Redux? Should we use mutating methods or should we use non-mutating methods? In the beginning, the answer was that for Redux, we should always use non-mutating methods, because non-mutating methods like concat or the spread operator over here and the slice and filter methods over here, in the context of arrays, these non-mutating methods give us new arrays. New arrays mean new references, and we discussed previously that in a reducer function, we need to return a new reference as the new state, assuming that our state is going to be either an array or an object. We need to return new arrays or new objects, and so non-mutating methods help with that. So in the early years of Redux, the answer was that we have to use non-mutating methods in the reducer functions. So a lot of developers, when they started to learn Redux, they found that this requirement of using only non-mutating methods was adding to the learning curve of Redux itself. Apart from the added learning curve of learning new functions, the code got even more complex when the state had a lot of nesting. And so to help with this problem, a new library came out called immer. And with immer, what we can do is we can use the much simpler mutating functions like push for adding an element and splice for removing an element, but we'll have to use them in conjunction with immer, and immer will help with returning a new array. A lot of developers prefer using the mutating methods listed over here, and so immer became very popular, so popular in fact that it has been included into the Redux toolkit library. We will discuss how to use the mutating methods like push and splice together with immer while we are writing the reducer function for the example that we are going to implement. So let me discuss this once again. So in the beginning, all Redux developers were asked to use only non-mutating methods in their reducers, but now we can also use mutating methods if we use them along with immer. In many cases, this option is a lot more simpler, so a lot of developers are using this option as well. So at the moment, Redux developers can use non-mutating methods or mutating methods along with immer. Immer is a very simple library, so we will discuss that once we finish writing our React component and reducer. So let us next jump over to our example that we wanted to implement. We will discuss immer towards the end of our implementation of this example.